Let's solve the initial value problem. dy dx equals 1 plus 3x squared over 3y squared minus 6y. And y of 0 should be equal to 1. We can do this by separating the variables. We will have therefore 3y squared minus 6y dy, and this is equal here to 1 plus 3x squared and then dx. All right, I meant to put here, let's see, a 3, not an e, so fix that. Now I need to differentiate both sides, so it's going to be y cubed minus, and that one's going to be, well, y to the second over 2, negative 6 divided by 2 is 3, so it's going to be 3y squared. You can check it because the derivative of this would be negative 6y. And then on the right side, I will have x, and then plus 3, well, x cubed here this way, plus the constant c. When you do this, sometimes people get confused. Why do you not do this? In other words, like plus c1 on this side, and then c2 on this side. So if you did that, then you could say c sub 2 minus c sub 1 is equal to a new constant c. And you could eliminate, therefore, this right here. And here you would have that c sub 2 minus, in other words, c sub 1. But now you can just call it big C, see? Apply the initial condition. So remember, y is 1 and x is equal to 0. So plug those in. You're going to have 1 cubed minus 3 times 1 squared is equal to 0 plus 0 cubed plus c. So on the left side, you're going to end up with, let's see, 1 minus 3 basically. So negative 2 is the value of c. So it means that now we get a differential equation solved by y cubed minus 3y squared is equal to x plus x cubed minus 2. Now this is an implicit curve basically. And also let's see where this is defined. So what I mean is, look what happens when you have 3y squared minus 6y. When that is equal to 0, that leads to division by 0 in the definition of dy dx. So factor 3y out. You're going to have y minus 2 equals 0. That means either y is 0 or y is positive 2. Now, for the domain of definition here in terms of x, when y is 0, what do you have? Plug it into this right here, into this implicit curve. So you're going to have 0 cubed minus 3 times 0 squared is 0 equals x cubed plus x minus 2. So when y is 0, you get this equation right here. So replace y with 0 and then move the x cubed to the front here. Now, one thing that solves this, hopefully you can tell, is x equals positive 1. That solves it, right? Because that would give you 0 is equal to 1 cubed plus 1 minus 2. So in other words, this is just 0 equals 0. It's true. X equals 1. When y, on the other hand, is positive 2, then look what happens in that case. Plug it in. You're going to have, so 2 cubed minus 3 times 2 squared. And that would be, again, x cubed plus x minus 2, picking up all the way across the top here. So on the left side, you're going to have negative 4 is equal to x cubed plus x minus 2. Move the terms over. So 0 is equal to x cubed plus x negative 2 plus 4. It's going to give us positive 2 right here. And hopefully you can tell this is solved by x equals negative 1. Why? Because look, it's going to be negative 1 cubed minus 1 plus 2. That's going to be here. 0 is equal to, that's negative 1 minus 1 plus 2. So 0 is equal to negative 2 plus 2, which is 0. It checks. So in other words, what this is telling us is the following. When x right here is equal to, let's see, positive 1, and when x is equal to negative 1, we get vertical tangent lines. So it means, in other words, we have negative 1 is less than x less than positive 1 as our domain of definition, essentially. I've added here a graphical representation of what we were talking about. I made this in Desmos.com, really nice website. So you see between negative 1, which is here, and positive 1, which is here, the curve relevant piece is this piece right here, see? Right there. Please leave a like if it's been helpful.